Hi, my name is Natijani Ilmi binti Zulkifli. Here I will present about introduction of fiber reinforced concrete. Fiber reinforced concrete is a composite material with increased post-cracking tensile residual strength, also known as tautness, as a result of the fiber reinforced mechanism provided by fiber merging the cracked surface. High modular fiber can also be used to partially or completely replace conventional reinforcement to improve concrete tautness for structural application. Other type of fiber, typically with a low modulus and a small size, can be used to decrease shrinkage cracking and improve fire resistance. A hybrid system of fiber is a more recent advancement in fiber reinforced cement-based technology that aim to optimize several material performance. Two or more different types of fiber can be properly combined in hybrid system of fiber to produce a composite with mechanical and physical properties that support from earth fiber. At servability limit state, fiber can be used to improve crack distribution and limit crack width. In some structure, fiber can also be used as a partial replacement for traditional reinforcement. These structures have a higher degree of structural redundancy as well as higher redundancy. Here it goes material properties. First, we will go through to the chemical properties. First is cement. Low heat Portland cement is used for the cement. The weight ratio of the cement content to the powder material composed of the first pozzonic reactant particle, the first aggregate particle and the second aggregate particle is between 30% and 40%. Next is first pozzonic reactant particle. Silica film is used for the first pozzonic reactant particle with a high activity. In this case, the material used for the first pozzonic reactant particle is not limited just to silica film. Instead, a compound selected from kaolin derivative, precipitate silica, classified fly ash, or the like may be used. Next is second pozzonic reactant particle. In this case, the first pozzonic reactant particle and the second pozzonic reactant are impalpable powder to be involved in the pozzonic reaction and make the cement matrix dense by the microfiller effect and cement depression effect of line particle including. It should be noted that the pozzonic reactant reaction is a reaction in which the pozzonic substance react with the alkaline substance produced by the cement hydration reaction to gradually form a hardening body, which contributes to long-term and stable strength development. Next, first aggregate particle. The type of fine sand used for the first aggregate particle is not limited. In this case, it can be obtained from sources such as sea sand, river sand, and crushed sand. Next is second aggregate particle. It can be made from silica sand, propylene silica containing powder, volcanic ash, rock powder, or other material. The mixed proportion gives a smooth grading curve and satisfies the upper limit of the grading distribution in a case where D75 grading is about 50 meter and D50 grading is about 10 meter. Next is plasticizer. Superplasticizer is a water-soluble vinyl copolymer with phenolphthalein and carbonyl group that is used as a plasticizer. Furthermore, the plasticizer to be used could be of one or more types. Next is water. Water is added to achieve a weight ratio of 10% to 50% of the total weight of the cement and pozzonic reactant particle. Furthermore, water is added to achieve a weight ratio of water to cement of 20% until 24%. Next is fiber. According to this embodiment, fiber can be chosen from non-fiber such as high-tensile steel fiber, amorphous steel fiber, or stainless fiber. Furthermore, one with variable roughness of fiber in the longitudinal direction of the fiber or one with variable sectional area of fiber may be used. Fiber can also be integrated by weaving several pieces of fiber into a cable, braiding, or twisting.
Assalamualaikum. My name is Alif Haika bin Bakri. I will be presenting about the materials properties, which is the mechanical properties. Firstly, the compressive strength. The presence of fibers may change the failure load of cylinders, but the effect of fibers on compressive strength values is minus 0 to 15%. Elasticity modulus. The modulus of elasticity of FRC increases slightly as the fiber content increases. It was discovered that for every 1% increase in fiber content by volume, the modulus of elasticity increases by 3%. Number 3 is flexure. Flexural strength was reported to be increased by 2.5 times when 4% fibers were used. The toughness of FRC is approximately 10 to 40 times that of plain concrete. Number 5 is tensile strength of splitting. The addition of 3% fiber by volume increased the splitting tensile strength of mortar by nearly 2.5 times that of unreinforced mortar. Fatigue strength. The addition of fibers increases fatigue strength by about 90% and 70% of static strength at the 2 times 100 cycles respectively for non-reverse and full reversal of loading. The lastly is resistant impact. Depending on the volume of fiber, the impact strength of stringy concrete is generally 5 to 10 times that of plain concrete. Thank you.
My name is Afzal. Today I will continue with the procedure, process and procedure. Uh, Material manufacturing process. Okay. First step is mixing step, which is the fiber is fitted into the cement matrix, which has achieved this destined fluidity during the wet mixing stage, and further mixed in the fiber mixing step. Weights and means. Okay, next is a casting steps. After that, the last step we have a curing steps. This will next we have standard test pressure. We use ASTM C1609, which means standard test method for flexural performance of fiber reinforced concrete using beam with third point loading. Okay, first, molded beams are instrumented. Second, next step we have testing occurs at a constant deflection rate. Lastly, we have flexural performance parameters are determined. Okay, that's it for the test. Next, we have a process material of application. Fiber reinforcement of runway, aircraft parking, and pavement. Next, fiber reinforcement of tunnel lining and slope stabilization. Lastly, we have fiber reinforcement of dams and hydraulic structures.
Kebaikan dalam menggunakan fiber reinforced konkrit yang pertama adalah punya kekuatan pembatalan yang tinggi. Yang kedua, dapat menanggung banyak tekanan tegangan. Yang ketiga, mempunyai ketahanan api dan cuaca yang baik. Yang keempat, teknologinya lebih canggih berbanding bahan-bahan lain. Yang kelima, dalam bentuk cair, ianya dapat mudah dibentukkan dalam pelbagai bentuk. Yang keenam, mempunyai kos yang penyelenggaraan yang rendah, yang murah. Yang ketujuh, lebih efektif untuk menggunakan dalam penggunaan membina empangan dan juga tempat jalan kaki. Yang ke-8, bertindak seperti anggota tega dengan pasangan minimum. Yang ke-9, sentiasa digunakan dalam bentuk peratuang untuk membentuk sebarang bentuk dan dengan jumlah pasangan yang sedikit. Yang ke-10, untuk latihan untuk menggunakannya lebih mudah dan ringkas berbanding dengan penggunaan bahan yang lain. Cadangan untuk masa depan yang pertama adalah kita menggunakan fiber dan juga rebar, kerana rebar terbaik untuk babak pertama, manakala fiber memastikan menyimpan rekahan kecil, tahan lama dan cantik. Yang kedua, kita haruslah menyelesaikan dengan baik dalam amalan reka bentuk dan kemasan campuran kita dengan berhati-hati dan penuh perhatian, kerana fiber akan meningkatkan kos konkrit kita sebanyak 10 hingga 15%. Yang ketiga, tingkatkan isi padu fiber dan juga aspek nisbah untuk mendapatkan konkrit yang kuat dan kurang rekahan yang dihasilkan. Yang keempat, saya akan mengusahakan untuk menggunakan gentian keluli berbanding gentian jenis lain, kerana gentian keluli dengan ketara meningkatkan ciri-ciri konkrit keras mulus yang bagi bahagian ini adalah 2 hingga 3 kali ganda daripada gentian kaca. Yang kelima, untuk memastikan sehelai gentian berfungsi, saya akan mengusahakan gentian terpakai yang lebih panjang daripada saiz maksimum aggregate.
My name is Uthm and I will be presenting the conclusion. The conclusion is the workability of RRC is low, but the durability of structure is very high. FRC can be used to lower the depth of a beam while maintaining its bearing capacity. For thin members or members that are too intricate for rebar, fibers are frequently the sole option for reinforcement. In some cases, we can replace the steel bars with steel fibers. Fibers are a great tool to reduce cracking and increase toughness, but be careful. Not all fibers are the same. The bridging action of fibers keeps the bond strength between fiber and concrete, so the compound will be stiffer. FRC have high capacity of taking shear stress, bending moment, tensile stress, and conventional concrete. That's all for our group. Thank you.